Okay, which allows us to solve for the normal force, n equals m2 times g times cosine of theta. So now we'll look at F net, tricky one here, in the x direction, which is equal to m2 times a, that acceleration. Now we sum all these things up, it's equal to 0, plus tension minus mu sub k times our n. So I'm going to actually take this equation from the y component and plug it right in here. So m2 times g times cosine of theta, and then minus m2g times sine theta. And just simplifying that a little bit, we'll do some scrolling. We've got m2 times a equals the tension, which we actually know, I'm going to have to plug that in from before, minus, I'm just going to pull out the factor of m2g in both of those equations. I've got mu times cosine theta plus sine theta. And let's take from that equation 1 from before, we'll plug in to tension right there, and get that m2 times a equals m1g minus m1a, that's from before, minus m2g times mu kinetic times cos theta minus plus sine theta. And next we just solve for a, so m1 or m2 plus m1 times a, I've collected like terms of a on this one side, is equal to m1g minus m2g times ditto, same thing. I'm going to solve for a equals, there's a gravity term, and then it's multiplied times m1 minus m2 times mu sub k cosine theta minus m2 sine theta all over m1 plus m2. Now we can do a little sanity check here and just look at these. We can say that the acceleration is going to be greater if m1 is greater, because m1 is what's pulling it downwards. It's going to be less if m2 is greater for two reasons. One, because there's more friction, that's that first term, mu k times cos theta. So friction will be less actually if the angle is greater, and maximum when theta is 0. And then the other thing that's causing the acceleration to be less is that it's just on a slope. And then the whole system weighs m1 plus m2, so we kind of imagine the total mass to be in the bottom of an acceleration equals force divided by mass. So that equation looks pretty reasonable to me, and I think all I need to do now is plug in numbers. It's 9.8 meters per second squared, and then times a dimensionless thing. There's 1 kilogram minus 0.25 is m2 times 0.2 is the coefficient of kinetic friction times cosine 30, and then minus 0.25 times sine 30, all divided by total mass, which is 1.25. And plugging that into my calculator, I get 6.52 meters per second squared. So that seems pretty reasonable. Let's see if it's up on our list. 6.5, so the answer is B.